Hello everyone. This is the lecture for homework 8 in Math 1111. Notice that the first problem we have, we want to find out which functions will best describe this. Now, I gave you a handout in D2L that shows all the functions and what they look like. So in A here, we have a straight line and the slope is positive. So that is our f of x equals x. B is a v. The v is the absolute value function. What we have here is what looked like the rational, except the piece in the second quadrant is usually in the third quadrant. When they're both above the x-axis, instead of it being 1 over x, it is 1 over x squared, because all your negative values became positive. The parabola is your quadratic function, x squared. You got to memorize what your functions look like. If you're going on to future maths, you're going to need to know. All right. For question 2, we have the graph of y equals x squared in front of us, and they want us to translate to make it the graph of y equals x plus 5 squared plus 4. Let's do a little remembering here. The basic format, y equals a x plus, nope, not plus, it's minus c. Oh, I lost b. Just don't worry about b right now. Minus c squared plus d. All right. Remember, if a, this one doesn't actually have an a, but we're going to get some. If a is bigger than 1, then it's going to stretch vertically. If a, if a is between 0 and 1, it's going to shrink vertically. If a is negative, you're going to have the reflection over the x-axis. A, in our case, a is 1, right? We have a 1, understood 1 in front of that, so our a is 1. Everything's nice and normal. Alrighty, so the next part, if d is positive, it's going to shift up. If d is negative, it's going to shift down. Now here comes the fun part. The c value. Notice there's a negative in there. All right? If it's x minus c, shift left, shift right. If x plus c, shift left. And I can explain all that to you in person if you like, but that's what you just need to know. So basically for this problem, we have a shift left and a shift up. So 0, 0, 1, 1, and negative 1, 1. If we shift left, it's going to go to the 5, then shift up 4. So that's going to be our point. If our 1, 1 point shifts left 5 and up 4, it's going to be there. And if our negative 1, 1 point shifts left 5 and up 4, it's right there. So this thing is going to be something like this. And of course it'll draw better. Whole lot better on the Alex system. Now we have the graph of y equals absolute value of x. So it's the same idea, even though I use the square, the quadratic here. For this one, same idea. With what's inside with the x, if it's plus, you're going to shift left. And if it's hanging out here outside, you're going to go up or down. And in this case, it's negative, so we're going to shift down. That's that information right there. All right, so 0, 0, whoops. 0, 0, shift left 4, and down 2. There we go. It's our new point. 1, 1 would shift left 4, down 2, be there. And then negative 1, 1, shift left 4, down 2. So our new graph, and I am drawing this freehand, just so you know, I'm drawing a freehand. It's best of my ability. And of course, the graph on Alex would draw better. Transforming these is just a glorious fun. Let's do a little note here. If y equals f of 2x, well, I'm not going to say 2. Let's just use a letter. We'll say bx. Whoops. Well, I'll tell you what. There we go. If you have f of bx, divide x values by b, sorry, keep y the same. Okay. If you have a times f of x, be a dot there. All right. You're going to multiply the y values by a. So in this one we have 2x. Let's look at where our points are. Where are our original points? Original points. All right, this is just a little note here. All right, original points. They are negative 2 and 4, 0, 0, and 2, 4. The 2 is on the X in front of it. So we've got the B thing going on here. So our new points we're going to divide X divided by B. In this case, X is going to be divided by 2. So you get -2 divided by 2, comma 4. That's going to give us -1, 4. Of course, 0 divided by 2. Oops, 0. Don't change the point. All right, so that's still 0, 0. And then 2, 4. It's 2 divided by 2, 4. And that's going to give us 1, 4. Because the 2 is on there, there's another little notice that you should remember, and that is if that's called the B, right? You know, we'll write this over here a little bit. If B is greater than 0, it's going to shrink horizontally. If B is less, no, sorry, that's not right. It will be in a minute, but not yet. If B is between 0 and 1, it stretches horizontally. And if B is less than 0, it's a reflection over the y-axis. All right, so you got some things going on here. Like we had up here, I talked about A that we didn't actually have in this problem. All right, that's why I called this A down here. This is what we'll have in our next part here. All right, so we got our new points. -1, 4. Remember, the X is changing, not the Y. 0, 0, nothing changed. And 1, 4. B is bigger than 0, 0. It's 2, right? So we're expecting this thing to shrink. And indeed, it shrunk horizontally. All right, so for this one, we have the piece out front. So that's our A. Our A there. So we're going to multiply our Y values by that value. Well, let's find our original points. So we've got 0, 0. And we've got 4, 4. All right, so our new points are going to have 1/2 multiplied by Y. So 0, X stays the same. And this one will be 0 times 1/2, which of course is still 0, 0. Our X's stay the same, so that's still 4. And the other one, Y, is 4 times 1/2. I do hope you know what 1/2 of 4 is. So that gives us the point 4, 2. So our new points are 0, 0, so that didn't change. 0, 0 hardly changes unless there's a shift left, right, up, or down. And 4, 2. Now remember up here, where'd it go? There it is. If A is between 0 and 1, and 1/2 is between 0 and 1, so if A is between 0 and 1, we expect to shrink vertically. And indeed, this shrunk down from there to there. So that is a shrink. All right, yay. Question 5. Now we get to put it all together. I just knew you'd like that. Okay. Of course, you've got all the buttons on the right-hand side on how to do this in ALEKS. We're going to kind of work through it by hand because not every course has ALEKS, right? So below is the graph of y equals x cubed. That's the basic. We're going to take that basic cube, still cube, see, still cubed. We're going to take that basic cube and we're going to transform it. Yay, transformers. Think of transformers. Well, this piece hanging off here, I just know that's going to be the shift up, right? The one inside is going to be the shift left because it's +1. And the number out front is what we're going to multiply by our y's. That's our 3. 3 is A. Let's go back up here. 3 is A. A is 3. It's bigger than 1, so we're expecting a stretch vertically. And we know that we're going to multiply our y values by that A. Okay. Math is our friend. So, A is greater than 1. I'm just going to say that. All right. All right, here we go. So, if you had a reflection, you would reflect it first. There's no reflection on this. Remember, that would be if there was a negative there or a negative there. There's no reflections, so we don't have to worry about the reflections. We want to shift it. We can either shift left and right first, or we can do the 3 first. It doesn't matter. I'm going to do the 3 first because it's right here. I've got these points right here I can use. And 1, 1, and -1, -1 are easy points to use. Of course, so is 0, 0. Remember, with the 3, we'd be multiplying these by 3. So 3 times that 1 is 3. So this point moves here. And this point, -1 times 3, would move here. It's bigger. We're expecting it to stretch. And so it does. Something like that. All right. That's that piece. Shifting left. Well, this part, we go left 1. So it goes to here. This new piece here goes left 1, which is here. And this piece goes left 1, which is here. So now it's doing something like this. And I never could draw these things very well. All right, that's your shift left. Now we're going to go up. We're going up 4. So that's this piece is going up 4. So 1, 2, 3, 4. It's going to be right there. This one's going up 4. So 1, 2, 3, 4. And this piece is going up 4. 1, 2, 3. 1, 2, 3, 4. So it's looking like something like this. We finally get finished with it. That is our final answer. So you can go back and pause it and see how we moved it piece by piece. We got that point, and that point. All right. If you're a math person and just want to do this mathematically, get those 3 points again. Mathematically. So we've got 0, 0. We've got -1, -1. We've got 1, 1. All right, that's going to become the 3 multiplies. Move left first. Move left first. I multiplied first. It was easier, wasn't it? So multiply by 3. So this is still 0, 0. This one becomes -1, 3. And that one becomes 1, 3. Alright, that was the y times 3. Should have been black, right? Because I'd use that in black. Oh! Make a big mess here. Make a big mess. Make a big mess. Okay. That was the black I used. Alright, so that became 3 times y. Gives us 0, 0 still. -1, -3. And 1, 3. Alright, then we shifted left. So that's -3, x minus 3. So that gives us -3, 0. -3, -4, 0. -3. I'm sorry, that's not a 0. Good catch, y'all. I know you saw that. -3. And -2, 3. And the next piece was our shift up, so that's y plus 4. So that gave us -3, 4. That's not what I have over there, is it? That gave us... Yeah, it is. No, it's not. What the heck? Did I forget the shift left? I forgot the shift left. I did the wrong shift left. Did the wrong shift left. My points weren't matching up with what I had over there, right? Shift left is 1. It's x minus 1. So that's going to be -1, 0. -1, -2, 0. Here we go. -1, 0, 3. Okay. Alright, which is what it was before we moved shift up 4. Unless I shifted up wrong. I may have to regraph this. Alright, so the next piece then should be y plus 4. Okay, so we've got, that one's right. -1, 4. That one's right. That one's right there. And then we got -2. I keep writing that wrong. It's not a 0. It's a -3. So that's -2. And y plus 4 is -2, 1. That's that point. And that's going to be 0, 7, which is that point there. So you can do it mathematically, which, as you can see, even hurts my head. Or you can do it with just moving them. So from now on, I'm just going to move. You guys can do the mathematical stuff. All right, so we have a graph in blue. That's our F. This is our F. And it's translated a whole number, that's important, of units horizontally and vertically. So there's no stretch or shrink. So all we're looking at is D or C in our basic graph. To obtain the graph of K, and this one's K, in red. All right, the original function is f of x equals the square root of x. But if you're going to deal with D and C, you've got x minus C plus D. All right, so remember this is our shift horizontal. I have a better idea here. I'm tired of writing. This is our horizontal shift, and this one is our vertical shift. All right. So, to write this out, x. Alright, so we see we start here, and x moved to the 2 to the right, so that's minus 2. And then y moved up to the 3. That's 2, 3 is that point right there. So we're adding 3. And that is all they're looking for. Doesn't matter what the function is. It's always going to have that something. Remember, we at the beginning I used x squared. Then we had the square root function. Same idea. Oops. Alrighty, math is our friend. Okay, so symmetry. Symmetry is just looking at it and seeing what you have. X-axis symmetry means that let me write it over here. X-axis symmetry. Just say symmetry. X-axis symmetry. We can fold over the x-axis and see same graph. Y-axis, guess where we're going to fold that one over? Yep, you got it. We're going to fold that one over the y-axis. And see the same graph. Symmetry is coming really important when we get to functions, more function stuff, because we talk about even and odd functions, and then it has to do with symmetry. So starting to understand the symmetry, it's not something to just kind of have fun with and then throw it out the window. Origin is you're folding over the x and the y. And seeing the same graph. Now I'm not sure what I'm writing actually makes sense. I don't think I've ever actually written this down before. But let's look at these three they gave us. All right. If I take what's in the top up here and I fold this down to here, well, there's nothing in the top. Nothing up here. So there shouldn't be anything down below. So it's not x-axis. It's not that one. If I take the left side and I take it and pick it up and fold it to over here, well, that line right there would be right there. And there's no line there. So it's not x-axis. Now here's the fun one. Origin. Origin would take the first quadrant. Well, origin would fold this piece down to here. Of course, there's nothing here, so we pretty much can tell it's not origin, right? Would fold this piece down and then would take this piece fold it down. Hang on, I got this. Fold it down. Okay, so you've only got this bottom piece, and then take the left piece and fold it over from here to here. Again, that line that's there would be there, so it's not origin either. It's actually none of these. So that's a none one. All graphs do not have symmetry. Let's take a look at this piece. If I look at the top, I see my semicircle. If I fold it down, that semicircle will fold over that line and be the same semicircle down here. So it definitely is x-axis. Let's check the y-axis. Y-axis, take the left half which is also a semicircle. Grab that, fold it over. That semicircle is going to fold over and create this semicircle. So y-axis is also a symmetry. Sometimes you get really good at seeing this without even really realizing you're seeing it. All right, origin. So we're going to take the top, which is a semicircle, fold that down, and then take this bottom piece, which is this quarter circle, and fold it over, which is this quarter circle, so it's also origin. It's all three of them. This makes better sense in person, so if you have a question, let me know. You have to kind of see spatial stuff. All right. So, C, here we go. We take the top half and fold it down. This lump should be down here then, and that mountain should be that valley. They're not there, so it's not x-axis. Feel free to stop the thing and look at that again. Kind of went fast on that one, sorry. Here's our left side. We grab this and fold it over. This piece goes here, so this lump should be here, and the valley should be here. That's not happening. It's not y-axis. But I bet you see it. I bet you see it. Okay, so I take the top half. We're testing the origin now. Take the top half. Fold it down. That takes this piece, that piece, that piece, that piece. Now take this corner and fold it over so that piece becomes that piece, that piece, and that piece, which was your original piece that was there, or down here, or however you want to look at it. It is origin. So have fun looking at that. Some people actually just, oh dear, tell me I did not erase everything on that page. Can I undo that? Undo. Oh, good. Phew, I don't know how I did that. Okay, so some people, whew, that scared me. All right, didn't want to have to start all over again. Some people actually can tell and rotate this thing, pick it up and rotate it around the axis. That's the rotation axle there, the center. And they rotate it around, and when they rotate it around, they see that this lump here, this mountain, becomes that valley, and that valley becomes that mountain. If you can see that rotation around the origin, then you have symmetry, origin symmetry. So if you see that rotation, you can see that too. So there's several ways to look at these to find things. Those are the ways I do that. I don't always rotate. Can't rotate always in my head. Right. Oh, let's do some math. There we go. No more graphs for a while, hopefully. All right, we have a function f that's defined for all real numbers, nothing imaginary, as follows. F of x equals 1/4 x squared minus 4 if x is not equal to 2. And 3 if x is equal to 2. We're asked to find f of -2, f of 2, and f of 5. So the issue is x equals 2. The only time they told us that was for the second one there, f of 2. All the other values, 5 does not equal 2, and -2 does not equal 2. So for f of -2, we're using the first one, which is 1/4 times -2 squared minus 4. And that is going to be 1/4 times 4 minus 4, which is 1 minus 4, which is -3. That's interesting. Okay. When f is that, okay. When f is 2, when x is 2, sorry, f of 2, x is 2, we're going to use this one. The answer is simply 3. And when f of 5, sorry, x is 5, 5 goes into this one because 5 is not 2. We have 1/4 times 5 squared minus 4. It's okay to say yuck. That's going to be 25 over 4 minus, gotta make 4 over 1 a common denominator. So that's 16 over 4, so that's 9/4. Yay. All right. You ever see errors on these? Let me know. Okay, this is fun here. Number 9 wants us to find the intervals on which the function is strictly decreasing. Strictly means the endpoints will be open. We're going to write our answer as an interval or list of intervals. Notice it doesn't say union of intervals. It's just a list of intervals. And we'll separate each with a comma and use as few as possible. All right, so you probably remember something back there somewhere. If you're reading left to right, always read left to right. Read left to right. Left to right. All right, so going up is increasing. Going down is decreasing. And if it's flat, that's constant. So we're looking for the decreasing. So the first piece is constant. Second piece is increasing. Oh, wait a minute, here's a decreasing. Yay, that's going down. Next piece is increasing. Wait, here's another piece going down. Decreasing, yay. So let me clean out some of those lines. So we have 2 places we're decreasing, and we read the x values. Read the x values. So the x value here, just different colors here, is 0, 3, 0 to 3, comma, the x values here are from 5 to 7. Remember I said it was all open because it's strictly decreasing. And so that is our answer. Number 10 says, here is a graph of a function g. Looks like a wild W. All right. We're going to use the graph to find the following. All right. If there's more than one answer, we'll separate with commas. We're going to talk about local minimums and maximums. So let's have a little thought here, process here. Local maximum is the y value. Occurs at keyword, the x value. All right. They're at the top of the hill. So you have something going up. You'll have an ordered pair x, y at that point. So you kind of probably have an idea about the local minimum. You can have more than one of these in a function. A local minimum y value occurs, again, keyword, at the x value. Bottom of the valley. Valley. All right. So it's going to look like that. And it's going to be something there with your x, y. Okay. So remember I said the key word was at? So our first question says all values at which G has the local minimum. It's not asking for the minimum value, asking for all values where G is located. So minimums are the bottom of valleys. So we've got a bottom of a valley right there, a bottom of a valley right there. So this X value is 4. That X value is -2. So -2, 4. Now you want the local minimum values. Now it's asking for the actual minimum values, and those are the Y's. So we got one at -3. And we have one at -5. And those are our answers. All right, this is fun. We have a g function such that g of x equals -1 if x is between -2 and -1, including -1. We've got the equal sign on that, less than or equal to. Got that. So that's including. Its g is 0 if x is between -1 and 0, including the 0, because it's got the equal sign on it. G is 1 if x is between 0 and 1, including 1. And G is 2 if x is between 0 and 2, including 2. So you have to remember that when the inequality doesn't have the equal sign on it, you've got open, and when it has the equal sign on it, you have closed. There's no x's in our g values, so these are constant functions, where constants lay flat. All right, so x is between -2. This time -2 is open. So we're going to have the point, this gives us the point -2, -1. And it gives us the point, that one's open. It gives us the point -1, -1, which is closed. So -2, -1, -1, -1. And then you'll draw the line between. Second set here gives us the open, -1, 0. And then it gives us the point 0, 0. So -1, 0, 0, 0, connect between. This one gives us the point 0, 1, open, and 1, 1, closed. Whoops, lost a 1. 0, 1, 1, 1. And the last one gives us the point 1, 2, 2, 2. And there it is. All right, now we have a function that's a little more exciting. It says the function f is defined as the x minus 2 if x is less than or equal to, no, sorry, that's not true. X minus 2 if x is less than -2, and 3x plus 2 if x is greater than or equal to -2. All right, so let's look at the first piece first. All right. This tells me we have the point. Hang on, I got this better than this. I can do better. Here we go, even better. All right, so I have, okay, x less than -2. There we go, that's what I want to do. That's what I want to do. All right, so x has to be the -2. You don't have a choice, but we know this one's going to be open. This is where our open piece is. Open. It's open at -2. Right? No equal sign on our inequality. All right, so that would be. I'm just having a bad time today. So we're using x minus 2 as our y value. All right. So that's going to be -2 minus 2, which is -4. So that gives us the ordered pair -2, -4, but we know that's open. Okay. So -2, -4 is open. There we go. Close enough. Now we need to find something that is less than -2. Well, -3 is less than -2. Put that into our problem, and we get -5. So that gives us the point -3, -5. -3, -5. Oops, that's not it. -3, right there. So now we're going to pick up the one-sided line that they give us, and this thing's going to go this way. Okay. Alrighty, next piece. Next piece happens when x is greater than or equal to -2. I have to come down here. All right, we have our x value. Y equals 3x plus 2. And then we'll have our point. All right. Again, we have the issue of x greater than or equal to -2. So we have to use -2. This time it's going to be closed because we got the equal on it. See? Equal on it. All right. So put this in. 3 times -2 plus 2 is -6 plus 2, which is -4. So that gives us the point -2, -4, closed. Notice that's the same point we had a minute ago. A closed point can fill in an open point. An open point never takes the closed point away. Closed has the priority. All right, so this inequality was x greater than or equal to -2. So greater than -2, there's lots of numbers greater than -2. I'm going to choose 0. I like working with 0 most of the time. So that's going to be 3 times 0 plus 2, which is going to be 2. So the point is 0, 2. So 0, 2 is up here. And then you'll connect the two dots and graph those. Is the function continuous? Basically, if you can drive your car along the little road you've just created and there's no gaps, no holes, it is continuous. If there's a hole or a gap, it would not be continuous. Four functions are given below. Either the function is defined explicitly or the entire graph of the function is shown. For each, decide whether it's an even function, odd function, or neither. Remember that stuff about symmetry? It's back. Even functions are the same as y-axis symmetry. And odd functions are the same as origin symmetry. There is no x-axis symmetry in a function because it wouldn't pass the vertical line test. Right. And the way I remember which one's which is odd starts with an O, and so does origin. They both have O's. Then the other one's even. That is how I remember that. All right, so look looking at our first wonderful problem here. If you recognize, you can rotate this piece. That's blue. Blue is blue. Okay, there we go. We can rotate this piece around the axis, and that hump would rotate around and be this hump here. So that is odd. You can also do the fold down and the fold across. All right. Notice this one is symmetrical about the y-axis. So this one's odd. Nope, sorry. Just made my symmetric about the y-axis, so it's even. Now this only works, this next part only works if you only have x to a power. There's no plus constants out here. If you had a plus c, this may or may not work, okay? But look at your exponents, 5 and 3. They're both odd, so it's an odd function. They're both even, you have an even function. Notice in this one you have a 5 and a 2. You can't have a mix, so that's neither even nor odd. And that concludes Homework 8's lecture.